We're now moving on to Chapter 7, which deals with equilibrium and stability criterion in one-component systems. And so far, not only in this course, but in MEB2, every sort of system that we dealt with, we would always have to find lots of different pieces of information. But one thing that we were usually told, or that we could easily figure out, was the phase of the system. Right? We are either told that what we were dealing with was a vapor, or a liquid, or a solid. Okay? And this was an important piece of information, because the phase that we're dealing with, or the phase of our system, that has a dramatic impact on the properties of the system, or on the properties of the material. Right? Not only its density, or how big the system is, but also its thermodynamic properties, its internal energy and its enthalpy. We saw that the enthalpy of a vapor is much larger than the enthalpy of a solid. And same thing with entropy, right? The entropy of a vapor, if we go to the steam tables, is much larger than the entropy of the liquid. Also, in problems that we dealt with, we've also looked at the transitions between phases. Okay? And we saw that you could go to different phases if you change your temperature of the system, your pressure of the system, or even the molar volume of the system, right? And so, if you want to go from the liquid to the vapor of water, you would heat up your water up to the boiling point temperature, or the saturation temperature. Or, equivalently, you could decrease the pressure of the system so that you were below the vapor pressure or the saturation pressure. Okay? All right, and so, understanding or knowing the phase of the system that you're dealing with is very important. And so in Chapter 7, what we're going to do is we're going to learn how to model the phase behavior of chemical systems and the properties of these different phases. Using the calculus of thermodynamics that we learned back in Chapter 6, calculus of thermo, and then also using our various equations of state. And so we'll see in this chapter that the ideal gas law will not allow us to predict or model phase changes, and we're actually going to have to use the more complicated equations of states in order to do that.